This is for review 8.4, 8.6. This is the second page, specifically for 8.5. We're looking to find the least common denominator. You look at your denominators, and they have to be some sort of a combination of the two. So our least common denominator is going to be x minus 3 and 2x plus 3. For here, you want to factor the problem, the denominators apart. You need to represent each one. So we need an x plus 3. We need a 3 and an x. And we also need an x minus 3. If each denominator had that, then that would be considered our least common denominator. We need to have least common denominators when you add fractions. So first we'll factor apart this denominator. So we notice that we have x, x minus 3, x minus 1, and that's being added to 5, x minus 3. We've got to get common denominators. So what this doesn't have is an x minus 1. So we multiply it to the top and the bottom to represent a value of 1, so it's not changing the actual value of the fraction. Now we have x plus 5 times x minus 1 over x minus 3, x minus 1. We can simplify that into x plus 5x minus 5 by distributing that through. And then a final result of 6x minus 5. The next question, we would want to factor the denominator of the second term, x minus 5, x plus 5. That's the difference of perfect squares. You can FOIL this to see that it makes the same. This first term is missing x plus 5 for a common denominator. So we multiply it to the top and the bottom. We're left with 3x times x plus 5 minus 2 over our common denominator. We can distribute this through to clean it up. And that was subtracting our two original fractions. Next we have complex fractions. That's a fraction inside of a fraction. You can look for the LCD. That's method number 1. In our notes, it was actually method number 2. But this is one method you could use. A common denominator would be 3x times x plus 2. So I'm going to take that 3x, x plus 2, and I'm going to multiply it to both the top and the bottom. I need to distribute that to both fractions in the numerator and the denominator. So I often like to write it on both sides. So when I multiply it here, my x plus 2's cross out, and I'm left with 3 times 3x. On this side, my 3's cross out, and I'm left with 2x, x plus 2. In the denominator, my x plus 2's would cross out, and I'm left with 6x squared. Here the x would cross out, and I'm left with 3 times x plus 2. I can clean this up some. 9x plus 2x squared plus 4x. Distribute 6x squared minus 3x minus 6. Typically, we like to reorganize that to make it official. 2x squared plus 13x over 6x squared minus 3x minus 6. You cannot cross the x squareds out. You cannot reduce the 2 and the 6. There's nothing else you could do with that. If factoring something out would help you reduce, that would be fine, but that won't be possible in this case. Let's look here at number 15. Number 15, the least common denominator is 4x and 2x minus 1. It's a combination of the different denominators. So I'm going to take that and multiply it to the top fraction on both sides and the bottom fractions on both sides. Multiplying it on top, those cross off, and I'm left with 12x squared. Nothing reduces here, so I'm left with 8x, 2x minus 1. In the denominator, the 4x would cross off, and I'm left with 5 times 2x minus 1. The 2x minus 1 would cross off, and I'm left with 4x squared. Clean this up some more. We got to distribute the negative 8x, 12x squared, minus 16x squared. Negative 8 times a negative 1 gives you a positive 8x. Distribute gives you 10x minus 5 minus 4x squared. And we can probably still clean that up some more. We call this a negative 4x squared plus 8x. And this would be a negative 4x squared plus 10x minus 5. You cannot cross out the 4x squares. Because they're being added to another term, it's not appropriate to cross them off. That's our final answer. Our story problem. Over a 20-year period, the number of doctors of medicine in the United States can be approximated by M equals 28,390 plus 693 t over 85 minus t, where t represents the number of years. The number of doctors of osteopathy can be approximated by this equation. We're going to write an equation for the total number of T doctors of medicine and the total number of DO doctors. So we're going to take the MDs which is 28,390 plus 693t over 85 minus t, and we're going to add that to our doctors of osteopathy. So, we don't have common denominators currently. So we have to multiply this side by the 55 minus 2t to the top and the bottom. We have to multiply 85 minus t to both sides for the top and the bottom of that fraction. So here we're going to have to FOIL. We're going to have to multiply the 55 to both terms, and then we're going to multiply the negative 2t to both terms. When we do that, we're going to get $1,561,451 plus 38115t minus 56780t times these two, which gives us a negative 1386 t squared. That would now be over 55 minus 2t times 85 minus t. And we're going to add that to this side. So when we multiply these, we're going to get 65960 minus, that's those two multiplying. Now we're going to do the outsides. 776t. Now we're going to do the insides. Negative 170t. Now we're going to do the last, which is a positive 2t squared. That still gives us a common denominator of 5 minus 2t over 85 minus t. When we collect our like terms, we're going to get 1627410 minus 19611t minus 1386 t squared. And that's all over our 55 minus 2t over 85 minus t. Quite a problem. So that is our expression of the total number of MDs and DOs. We simplified it by collecting all our like terms. Now, if our equations were from 1980, and they want to know the number of doctors in 1990, then we need to substitute 10 into each of these problems. When you substitute 10 into our MDs, we're going to get 47093. Those are our MDs. And when you substitute 10 into the DO equation, we're going to get 18.74.